morning!
Well, if you knew what was going on behind the scenes. Good morning, everyone. Happy Super Science Saturday to all of you.
Happy Saturday.
Marissa, thanks for joining us. We see you there already. Good morning to you. Hi from Masato and Shinji. Hello. Good morning.
Hi.
Good morning, Ursula. Good morning.
Everyone's
How are
very
you?
perky this morning.
They are on it.
Yeah.
They are on
YouTube
it.
didn't want to be on it this morning.
They didn't
it was
want
like,
to be on it.
You're not going live, but we're here. We
YouTube
did it.
was like, what? Oh, Mark and Ellie are live. Go.
Morning, Eagle Eye 18.
Oh, what's up, Eagle Eye?
How is everyone?
Yeah.
Prepped and ready
Big
to
shout
go.
out everyone for joining us this morning. Hope you're having a lovely Saturday.
Yeah.
We have had a lovely start to the morning. And we have just let the fire department know that we're going live again.
We rang them in advance this time. It felt like the polite thing to do.
Just to let them know. We thought it would be kind of just nice to that they were aware that we're about to do stuff.
Yeah,
again.
just in case. Like, I think, even if our experiments are not due to involve fire in
Which
any
they
way,
are,
shape,
by the
or
way. They totally are.
But I mean, in future, if none of them are going to be, we should
bring them on the show when they're here.
We should.
Bring them in.
Yeah, we should let them know, just in case they want to learn some science on a Saturday morning,
Bill from the fire department. Join us, Bill, here on a Saturday
Come
morning.
on in, Bill.
Yes. So we're going to start with last week's challenge solution to the challenge of last week.
Solution.
Hit him, Ali.
Yeah. Okay. So the challenge that we set for you last week was to empty a 2-litre bottle of water as quickly as you possibly could. So the rules were that the water had to be...
Roll it out the window. Get rid of it.
Get rid of it. So the only things I said is that it had to be full to the brim. We're getting the full 2 litres, all the way to the tippity top, and you couldn't alter the bottle in any way. So you couldn't just like slice your water bottle in half and tip out the water. That wouldn't really work.
I'd like to see someone do that though.
So we've come up with a few different methods.
Graham says chug it. Chug.
Imagine if I chug too.
Everyone's at home's doing it too. Chug.
That definitely would not be the fastest method.
I think you should try. This is all about experiments, Ali, and we have to try many different methods before we reach the correct one. And I think showing the guys at home the different methods that can be explored is an excellent way to learn together. Isn't that right, Graham Knight? Chug.
Okay, so what we've got here is we've got a basin just in case. I just don't want to tip it out all over the table.
Yeah, but that's good.
It feels like a bad idea.
Electronics.
We did have a lot of water on the table last week after a certain explosion happened, so we're not going to do that.
Yeah.
So what you'll notice is if you just turn your bottle upside down and tip all the water out of it, it's gonna like glug its way out because there's a lot of.
Did you say chug?
No, I said
chug.
Stop.
Oh, sorry.
Because the water's coming out and the air is trying to get in to replace the water that's coming out. So that's not the most efficient method. So one way that you can do it is if you get a straw with a little bendy bend in it, what you can do
You gonna do it?
I'm not going to chug the water, no.
Well, you're going to do the straw thing.
Yeah, I'm going to do the straw thing.
Do it.
So if you put your straw into your bottle, and as you are tipping the bottle out, you're going to blow into the straw to get that air in there nice and quickly. I have towels over here. It's okay.
Good.
It's okay. Ready?
Just helping. I'm helping. That's pretty fast. Unbelievably fast.
Yeah. So it just helps you getting the air into the bottle faster to replace the water, and it's forcing the water out the bottom. So that's one method.
That was
so if you
really
came up with
fast.
that, thank you. We're going to use a different method this time though.
Yeah.
So we're going to do it again. I'm going to show you a different method. The straw one's pretty good.
Yeah, you're going to fill the bottle again?
Yeah, I'm going to fill the bottle again. Yeah.
I really would have liked to. Could anyone time that? Can anyone go back and see how long that took? That took like...
A couple of seconds.
A couple of seconds? Like 2 seconds?
I'd say like 3-ish. Like 3
Yeah,
seconds
it seemed
maybe.
pretty nippy.
Okay, so let's do another one. Nippy. This time we're going to do something a little bit different. So we're not going to use a straw or any power of air or anything. I am spilling a lot of this water, but you know what? It's okay.
Yeah, they can see.
That's what the basin's for.
Yeah, okay.
Oh, that was kind of heavy. Okay, so this time what we're going to do is we are going to use a shape that appears in nature. And we're going to use a vortex. So this time what you're going to do is when you're turning your bottle upside down, you're going to swirl it around in some circles, and we're going to see what happens this time. Ready?
Let's do it. Okay, swirl it.
And you should see like a tornado forming.
Oh, that's fast.
Give another little swirl.
Super fast.
Pretty fast, fast, yeah.
Yeah.
So what happens with the vortex is it creates a kind of a gap through the middle of it. So there's a path for the water to go through. So the air can go up through the middle, and the water can come down the sides.
Because you might think the bottle is empty right now, but it's full of air.
Yeah.
So if you want water in, air has to leave. So they have to swap places.
Yeah.
So you're just providing a nice path for them easily to swap places.
Because otherwise, if it's just full up with some water and it's starting to glug, what's happening is some water's coming out and then some air's going in and then some water's coming out. Whereas with the vortex, you're streamlining the process. So air can get in at the same time as the water's getting out.
So water is rushing around in that kind of circular form, just like tornadoes in nature, and giving you that column that the air can go, and the water can go.
So there are 2 methods. So let us know if you have any other methods of emptying your water bottle really quickly. If anyone can chug 2 liters of water faster than we could empty it with the straw, I'd be really impressed.
Ali, I think you got to do it.
I will puke everywhere.
We want to see it. It's prime time Saturday morning viewing.
Yeah, that's what the people want on a Saturday morning. That's it. So that whole idea of the tornado in the bottle thing is something that we've investigated before.
We have, yeah. It's really fun, and it's something that you can do at home as well. They're very simple. It doesn't need very much. You just need bottles. We got ones shaped like this because, again, we're creating that kind of vortex motion. We found that these shaped bottles work quite well.
Yeah, and this plastic connection thing here in the middle is called a tornado tube, and it's just a nice way of being able to connect the 2 bottles together. You can do it at home with like tape and stuff, but it can be a little bit messy.
Yeah, it works fine. We used to do it with tape loads, so we get this kind of strong tape, so this type of tape like this. Just get 2 bottles and just wrap it around really tight. And again, remember, before you do that, make sure the water's in it.
Yeah,
you can't
water
do that
in it before you seal it.
And we've just coloured it just because they look extra cool and nice.
We got that cool set of food colouring, in case you haven't noticed. Now we use it in every experiment we can. So
we finally have a tornado race now.
We're gonna have a tornado race, yes. So you need to
physics.
You need to physics. You need to choose your competitor. Blue, red, or green.
Ali, I had the red and you took it away. Give me the red back.
I just want to make sure it was the choice that you were making.
What have you done something here?
I'm gonna go with green.
I think Ali's set something up here.
I'm gonna go with green. Okay, so we're gonna have a race. We're gonna see whose bottle will empty the fastest.
Okay, there are rules though.
Okay.
There are rules. Again, you can't manipulate the ball, you can't push, you can't squish it.
No squeezing, no.
Now, you might notice at the end there'll be a little bit in it. What's our call on that?
You roll, you gotta vortex it again. The water can, all the water has to empty using a vortex, no other method.
Okay. And we have to start hands off the table on the
knees.
On the knees.
Hands on the knees.
Oh, you get that thing. Okay.
Just kick your bottle off. Yeah.
Okay. And the final judges are the guys at home.
Yeah, okay. If there are any comings and goings about the result.
Firstly, place your bets right now. Who do you think's going to win? Mark, the red team, or
Ali, the green
Snotzers
team?
over there? Snot green over there. Do you think Danger Red or Snot Green's gonna win?
There's a lot of green today.
Oh, there is actually. Yeah. Stop trying to take me out of my mindset here.
Green.
Focus. You're playing mind games, Ali.
I'm not. Oh, Eagle Eye team voted for Mark.
Yes.
Thought we were cool.
Get the red team going. Blue. There's no. Oh, you were suggesting. Okay. Red team.
Come on, green team.
Go banana.
Okay, I think we just gotta go for it.
Yeah, okay.
Okay, hands on the knees. Hands on the knees.
Okay. Yeah. Okay.
That's orange. It's got...
That's not orange. It's red.
It's pretty red.
You red.
A lot of votes for red. Does anyone want to vote for the green team? Come on.
If I had a collar, I'd put it up right now. It's just...
Green! Yeah! Press Marissa.
Marissa, it's fine. I know you're just saying it to make her feel better.
Okay, let's just do the race. Okay, you ready?
Yeah.
Ready? In. You can call it.
Yeah, I was about to say.
Knees, please.
I'm talking. 3, 2, 1, go.
Yeah.
Yeah.
Go on, go.
Yeah. Okay. Ready?
Yeah.
Just make sure I don't hit you with my elbows. My spin. Okay, ready?
Yeah.
3, 2, 1. Before we go. Go! Okay.
That's so
you can't. Okay, my torch. Check that out.
My
tornado's going. Get them really nice and close.
Oh, your tornado is larger
we got two
than
good ones
mine.
going. Oh, they're pretty even though.
No, yours is going faster.
No, I think
they're pretty even.
We've seen them go before. No, come on, red's in it. Come on. Come on.
That was green.
No, it wasn't. It wasn't. I was about to say a draw to be nice. To be nice, but that was totally red. That was going to be... was going to be nice and say a draw, but if you want to play that game, it was totally red.
It was green.
I think red.
I think green.
What was it? You guys can let us know. VAR. Yes, please. Just get the assistant referee over here.
Marissa says it's the tie.
Yes,
Marissa,
Ali is a twat, correct, but that's not what we're talking about, VAR. To tie, I think it did seem like...
Do you want to have a rematch?
Oh, really?
Yeah.
Well, now is it best out of 2 or best out of...
Well, if we
I think it was a tie.
Green,
it was not green. Hello, Alistair, good morning, but listen to you. Larry, listen, let's go again.
Okay, let's say that one was a tie, and then the winner of this one wins.
Yeah, okay.
Okay. This time I'm saying 3, 2, 1, go.
Yeah, that's fine.
Yeah. Don't make me give you a time penalty. In 3, 2, 1, go.
Okay.
Tornado's going.
Oh god. Okay.
Fleur, I didn't see it, but I think it was green. Thank you, Fleur. Fleur understands. Oh, it's totally green.
Oh, it looks like...
it's green. 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 It's green.
Oh, shoot!
It's still one.
No.
So do definitely.
It's 1-1. It's 1. I won the first one. It's 1-1. Hey, where's that water coming from?
Yeah, they might leak a little.
Those are fake hands. I think you've been leaking out your water here.
Yeah, just slowly reducing the volume of the water.
That's green. Is that not?
That's red.
No, it's not.
There's red water right there.
I'm letting you people know at home. This Russian doping athlete over here there's green water on the table. She has been exiting water from her tube.
Do you know what? I actually purposely didn't pick the blue one because there is so much blue water on this stool over here, and I was like, that one's just leaking everywhere, so I'm not using the blue one.
I think there's going to be an investigation. I'm getting the athletic agency to investigate this.
But what you can also do, so we just had these bottles filled with water, but you can add some other things into your tornado tube if you like.
Yeah.
Another thing that we did was we got some clear lamp oil. And we obviously coloured it because that's what we do. And you'll see that the oil stays at the top because oil and water don't mix. And we got special dye that's for dyeing oils, because if you put normal food colouring into this,
it won't mix.
It'll dye the water. It won't dye the oil. So do you wanna give this one a go?
Yeah, so this one's quite tricky, but you see different densities, they don't mix. So we're gonna hopefully show you a cool vortex using the lamp oil. Because again, water and oil don't mix. They're different densities, so they'll separate, and you might see a little cool...
There's a lot of debate going on in the comments as to who won that.
I'm with Sanaram that red won both matches.
Green didn't cheat.
The water particles cheated.
Greeny had cheated. It's got very competitive.
Yeah, Alistair called you a cheat, Ali.
No, you think he's calling you a cheat.
Huh?
Alistair was on my side, so I think he's calling you a cheat.
So again, circular motions to create that vortex. Oh, nice! Check it out! Check it out.
So you got a very specific blue vortex and a red vortex here, so you can see really nicely that the oil is in the centre here.
Yeah.
And that we've got the water on the outside. And again, the air is moving up through that central column, emptying it out. This is not a fair race.
This is a race. This is a race. This is a total race.
They're different.
This is a total race. Everything's a race.
We started at different times.
This is crap ball. Yes!
You squeezed your bottle. That's cheating.
I didn't. No, we can look back.
We said that was one of the rules. You're cheating?
Well, if yours would like to finish any time this fortnight or side of Advent, we'd be all delighted.
Advent? Advent's the thing soon, is that? That's a thing.
Are you quite finished here, Red?
No, it's taking a time. It's taking a time.
It's taking a time. What is time?
We can all just sit.
Gravity.
We can all just sit in silence and watch this go if we want to.
You can. Just full stoppage. But try this out. It's so simple to do at home. Just get 2 bottles, tape them together, and circular motions create that vortex so the air and water can swap really fast. And have your own tornado races at home. That was fun.
That was fun.
That was really fun. Now, those of you who tuned in last week might have seen a bit incident, and we had a lovely. Well, let's just show you actually.
Yeah, we're going to show you what happened last week.
We had mucho fun last week.
There were a lot of laughs.
Mucho fun.
Mucho fun.
All right.
Okay.
Keep your eye on the bottle, experiment. It was mucho fun.
Doing it.
Oh, very cool.
Ooh, smoky.
Lots of smoke. Lots of laughing.
Lots of water all over the table.
Look at the pot.
So this is one of the experiments that we
So
did.
we
moved on. We were like, none the water. It's totally fine. And
I'll be back in a moment.
I can't believe it's been 11 episodes and only now have we set off the fire alarm.
Yeah.
Yeah, we did that last week.
Yeah, so we thought this week, let's top it. Let's bring the fire back. So we got a great experiment that we're going to show you how to do at home.
Yeah. Yeah, this one you can do at home.
Yes.
Yeah.
But parent supervision.
Yes, always. If it involves a flame in any way, shape or form.
Yes.
Parent supervision. Also, safety.
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 Okay, absolutely excellent. What we're using for this, so we have a big bowl. And inside the bowl we have water. And we have some fairy liquid. So there's a mixture. Let's get the mixture. Yes, it's bubbly. It's sudsy.
I can make you some more bublés.
More bublés.
More bublés.
Michael Bublés.
More Michael Bublés.
Get some more Michael Bublés. Okay. Thank you. Good bubbles. Good bubbles.
Thank you. I've been
Very
practicing.
good. There you go. That's the experiment. Try that at home. It's super interesting.
Use a straw to make the bubble. No.
Yeah. That is one to try at home. The next one is not one to try at home.
Do not try this at home.
So again, we are in Explorium. We're here in our lab where we've lots of really, really cool things. And we've got some flammable gas. That's where we're going to leave that one, folks.
Yeah.
We've got some flammable gas.
On that note, we do also have a fire extinguisher on hand. It's over here. We've got lots of safety equipment. We have some water on standby. Do not try this at home.
Bill from the fire department is closely watching as well. Bill, we'll be completely fine.
Yeah.
We got it.
Promise.
We got it.
Promise.
Okay. So again, we have a gas here, and the gas is flammable. You'll have seen us use liquid alcohol before as a fuel or propellant, so things that can ignite. So this is a gas under extreme pressure. It's compressed and it is flammable. So a very flammable gas. So we put that in our mixture of water and fairy liquid. So we have lots of bubbles. And what we're going to show you then is the fire.
The fire,
Thank you. So what we plan on doing then is to show you how flammable these gases are. So if you were to pick them up like this, so you can see that this is a flammable... Oh God, my hand! I can't wait to see her face.
I was like, are we not going to explain it first? I was like, I thought we were doing it with the spoon first. There was a whole warning order. We didn't even get our safety on.
I just want to see your face. A very flammable gas.
Your hand?
Why, thank you. Now, let's take it back a few notches.
Yeah. Jumping ahead all over the place. Put your safety on.
I can't wait to see Ali's face. I cannot wait to see Ali's face.
It was very warm, actually.
Yeah, it's really, really nice. So again, what we have, so we have our mixture here and we have our flammable gas. So inside there's air, there's oxygen around it, we've got some fire and we've got our fuel. So we can make a flame. So when you ignite that, then you have your flames like that. Very, very cool. So pretty nice. It's like your flaming cereal. So what would you like, Cheerios or flaming cereal? What would you like?
Crunchy nut cornflakes.
Crunchy nut cornflakes.
It's always crunchy nut cornflakes. You know this.
Yes. Now, again, there's a reason my hands didn't burn off. Again, because we use science. Like everything on this show, science is behind everything that we do. So in our mixture, again, we have our water and fairy liquid. Fairy liquid is just to help it make bubbles.
Yeah.
But our water is really the key to this and my hands not burning.
What would you
like? The flammable, please.
Oh, sorry. I put it to the side for safety when the fire was out.
So we're gonna make our bubbles. So again, you have the mixture of the gas in fairy liquid.
So the gas is getting trapped inside those bubbles. So instead of our bubbles being filled with air, they are full of that flammable gas. Okay. Put your safety on, sir.
We have here then that mixture. Okay. So with that, thank you. Oh, what did you put? You put them on my forehead.
I couldn't see what I was doing.
So again, we have that mixture right here, and my hand is covered in a layer of that water and liquid soap. So water has what's called a very high heat capacity. So it takes a lot of energy to heat up the water. So when I light those bubbles on fire, my hand is covered in that layer of water, which absorbs the heat energy and it doesn't burn. So it helps me do things like that. So again, science being absolutely awesome and very, very cool.
But again,
let's get some more in there.
Do not try this.
This is not something to try at home. Again, this is something you can show your teacher. Your teacher can try out for you.
Or you can just watch us do it.
Yeah.
We do it so you don't have to. That's a lot of gas.
That's a lot of cool bubbles.
Yeah, it's a lot of bubbles.
Okay. All right. Ali, let's do it.
Okay, you ready to go in?
Okay, I am indeed. Okay. Okay, I'm going to give you this.
Okay.
And let's get I'm gonna get my two hands in. Okay.
We never practiced this.
Okay, so again, covering my hands in that mixture. This is a lot of bubbles.
That is a lot.
Okay.
So we're wiping the bottom to make sure none of it drips downwards.
Yeah, we don't want any drippies, drips.
And we're going to move the large bowl of flammable things away. Just in case it drips in.
And this is going to be like the most awesome football celebration you've ever seen in your life.
Imagine if a footballer did this. Okay.
Okay.
Ready?
Yep. Woo!
Woohoo! That one's still going.
Yeah.
Nice!
Very cool.
Fire hands!
Juggling fire. You're playing with fire here, Mark. You're playing with fire. Literally.
How's it feel? We're going to fill the bath.
Eagle. Alistair, do not fill the bath. Even Marissa's laughing at Alistair.
That was pretty cool.
Yeah.
So again, like we said, do not try this at home, but we are going to show you an experiment that you can do at home to investigate the heat capacity of water.
Absolutely. So again, there's a reason, and a very cool reason why my hands are not burning.
Yeah, how do they feel?
Right now. So yeah, of course it's a little warm.
It smells a bit like
fire.
burning in here, but that's just because that flammable gas burned up really quickly. So I can't believe we're doing this again, but this investigation, this experiment that you could do at home is going to involve balloons.
Yeah, we love a balloon.
Do we?
I do.
I famously do not. So what you're going to do is you are going to use a balloon, you're going to use a candle. Let's use the big candle.
Okay.
Just, a bit more visual.
Why not?
And we are going to use some fire.
Some fire.
So what we're going to do is we're going to light our candle, like so. And we're going to blow up a balloon.
Yes.
As normal.
Okay.
Wonderful. And you're going to see, excuse me,
Let's
candle.
use the big candle. We're good.
Thank you. Okay. I'm gonna move back because I know what's going to happen here. So if you fill a balloon with air and you bring it close to an open flame,
even I'm like, whoo.
You'll see what happens. Go.
Okay, so I think we all know Eagle Eye's like, pop them.
Well, yeah, okay.
Yes, Marissa, this is definitely something that you can do at home. This is an experiment that you should definitely try at home again. Investigating the heat capacity of water. We just took our understanding to the next level to do some fire bubbles.
As always, because it does involve an open flame, adult supervision is very important.
I love a popping balloon, but this is I'm getting a little... Okay, so we have a balloon full of water. And
full of air.
Full of air, sorry, yes. And when we put that balloon over the air...
What's wrong with you?
It's fire, Ali.
Your hands were just on fire. It bursts instantly. Instantly. So, as you can see, when the balloon is just full up of air, it doesn't really stand a chance against the fire. But if you fill your balloon with some water, things are going to be a little bit different.
Like we've seen in my hands on fire experiment.
In my hands are on fire.
In previous episodes, such as Mark's hands on fire, we've seen that the water was absorbing that heat energy. And that was protecting my hands from absorbing the heat energy and burning. So water can absorb heat and has a great potential to absorb heat. It's called a great heat capacity. So if you want, you can puke in the balloon. Little balloon vom. Okay. So now we have some water in the balloon. So let's see how those two different experiments differ.
It's not even a lot of water. It's just when the balloon was empty, I filled it up with water. So it's only a small amount in it, just down here at the bottom. And we're going to see now, same balloon, well, same type of balloon, they're from the same bag. So if we bring that balloon with water close to the flame.
I believe in science, Addy, but okay.
I'm so mad at you today.
Okay, well, you see the other balloon burst instantly, but this balloon is not bursting. That water is absorbing the heat. It's taking that heat away from the balloon, so the balloon can't heat up enough to burst.
You can even see on the bottom here the burn marks from where the flame was.
Yeah, so
now,
we are doing it, just in case you think we're not.
With this one, if you're trying it out at home, just be careful where you're putting the balloon into the flame. So you want to make sure that the flame is directly below where the water is. So if you fill this balloon, I'm not going to do it because it's going to make a mess. If you fill this balloon with water, so the water comes to here, but you bring the side of that balloon to the flame, there's no water protecting it there. What are you doing?
Nothing.
There's no water protecting it there or absorbing any of that heat. So your balloon's gonna burst anyway.
You believe in science, Ali?
Oh God. I'm so jumpy. I'm so jumpy today because we're using balloons on fire. It's like the worst combination.
You believe in science, Ali?
Yeah.
Yeah, you believe in science. How much do you believe in science?
It's kind of what I base my life off, so yeah, kind of a lot.
Okay. Do you trust the science enough to try this over your head? Let us know. Let us know if you would like Ali to try the balloon water experiment over her head. Put her head where her mouth is.
See, again, it comes down to I trust science. I don't trust you.
I beg your science?
I beg your science. No, I don't trust
Another
you.
balloon.
I don't trust you. Over Mark's head.
Who said that?
Fleur.
Of course, it was Fleur. Over Mark's head. Over her head! Take her head! Off with her head! I think we're gonna do it.
Okay, make sure you put water in there.
Okay, well, of course. Okay.
Okay, we're gonna use a fresh balloon because this one has been heated
definitely
up a little
something
bit.
you can try at home. Again, because we have an open flame, parents, school guardians, whatever, please make sure
So
that
with
this is done
one,
safely.
what you'll find is if you hold the balloon over the flame for long enough, the water will eventually heat up and the balloon will burst. But it should be good for a good few seconds.
Yeah.
We haven't actually tested how long it would go for because
Let's do it now, sure.
Not over my head. That's
okay. So we have our balloon, and we just use the funnel, but you can try another way as well if you don't have a funnel at home. Okay.
Someone overfilled their balloon.
Okay. So here we go. So Ali, you get center stage. Would you like to place the smaller one on it so we're in shot?
Yeah. I think
let's
so.
try that one.
Just so everyone can see.
Okay. So again, definitely something to try out at home. Investigating the heat capacity of water. So I have my balloon and the water is inside it. You can hopefully see it inside it. And
I'm gonna move back a bit.
Ali is going to place the candle on her head. We're going
Once again, I trust science. Don't mess with this.
Huh?
Don't mess with this.
Wait, where is the... I need this one. Just...
No, don't, because no, genuinely, if you pop one over my head, I'm gonna get a fright and I'm gonna drop a flame.
I'm not popping it over your head. You can trust me. I'm not popping it over your head. I'm gonna show you. I'll even leave it there.
Because if you pop balloon on my head, I will get a fright, and you know there is a flame involved. What are you doing?
I'm moving this in case water explodes out the back.
Oh god. What? No, I heard you.
No, I'm gonna.
I heard you.
I was just placing
I heard
that
you
there.
move the blade behind me. No.
Okay, come on. Look, water's in it. Okay, here we go.
No cheating.
Marissa is wishing you good luck. We have. Oh yes, we have. Okay, Anne wants over Mark first. No, Anne.
No.
Okay, so we're gonna try to. Sorry, you just wanted to do it. Okay, we have our water and we're placing it over your head. You shaking?
I was just trying to get comfortable.
Okay, here we go. So putting the balloon over Ali's head. Here we go. Okay, so right over her head. Check it out.
I'm watching you in the screen.
The science works, and you can see that the balloon was really burning there. Very, very close to exploding.
Oh!
But check it out.
For not exploding it on my head.
The water trying to heat up, absorbing that heat energy away from the balloon, so the balloon did not burst. You look very relieved.
Yeah, I am. Yeah. So do try that one at home. Be responsible with fire.
Definitely, always.
At all times. So I think what we've got left, I need to set a challenge for next week.
Yeah. Next week's challenge.
So the challenge for next week is you're going to actually reuse that bottle that you were using earlier on. I have a sneeze. I'm so sorry. It's gone. So your challenge, again, is involving a bottle. And it's also involving... Did you use all of the balloons?
You can have this one.
Use all of the balloons?
Yes.
Okay. A bottle and a balloon. And my challenge for you is to get a water-filled balloon inside this bottle. Not this bottle, any bottle you got.
Yeah, specifically.
You have to come and get this bottle.
Come track her down.
A balloon and a bottle, and try and get a water-filled balloon into the bottle.
Okay.
Yep, that's the challenge.
It's got to be in the bottle.
In the bottle, full of water.
This has got to be full of water.
The balloon has to be full of water. The bottle is not full of water. Okay. So, balloon, full of water, inside, bottle, full of air. That
is your challenge for next week. As like always, let us know on social media how you're getting on. If you're trying it, if you try out any of the experiments and demonstrations that we're doing, also let us know. We would love to see you having fun with them. Possibly getting the water on your head and stuff like this, and exploring the heat capacity of water. That would be really fun.
Totally. Totally really fun for everyone involved.
So yeah, we want to see your pictures and videos, so send them into the Explorium social media accounts and tag us so we can see all the fun science that you're getting up to as well. And before we go, we're going to leave you with a science story of the week.
Oh, it's a good one.
Because it was really cool. SpaceX were at it again.
God,
revolutionizing
so good,
space travel. They got their Crew 1 capsule up to the ISS. Very, very cool. And it was a dark launch, so it was a dark launch.
Oh,
so,
it looks extra
very
cool. Fiery.
Yeah, so check out the launch, which happened on Sunday, last Sunday.
0. Ignition.
And resilience rises. Not even gravity contains humanity when we explore as one for all.
Propulsion is nominal.
That's the word we want to hear. Stage 1 propulsion is nominal.
That was really cool. So it brought 4 astronauts up to the International Space Station, and they are going to be there until April.
Yeah, 6-month mission. First time operational mission.
Yeah,
on SpaceX.
Falcon 9 rocket.
Yeah, 27-hour journey.
Yay, space. Yeah, 27 hours.
27-hour journey.
It's a long time, like.
It was Eagle Eye. It was a late launch, so it's probably
past bedtime.
Past my bedtime.
Oh, so, I love going to bed early, so like I was not staying awake for that.
Okay, sounds like you want to go to bed now. Thank you all for joining us this morning. We hope you have a fantastic Saturday. Do whatever you wish. Try out some of the demonstrations. Definitely show us. We are so happy that you're joining us, and we hope to see you again next Saturday. You can also, in the meantime, you can check out some of the fun videos that we created for Science Week. And they're all on the Dunleary Ratdown Libraries page. So DLR Libraries, if you bang it into YouTube, it will come up a series of 7 episodes where myself and Ali do some crazy things exploring the STEM world.
The STEM world.
Yes. So we're going to show you a very quick
teaser. No, we're not.
No, we're not. Go check it out.
As always,
just go check it out.
As always, if there's anything you would like to see in a future show, please do just let us know. You can message us on social media or pop it into the comments here, and we'll see what we can come up with.
Yeah.
We love to learn what you guys want to learn about.
Yeah. So guys, have a fantastic Saturday. It's been a super science Saturday here, and you guys have a super whatever it is you do Saturday.
Bye.
Bye.